discussing object modeling. Object-oriented analysis describes an information system by identifying things called objects that represent a real person, place, event, or transaction. Object-oriented methodology is popular because it integrates easily with object-oriented programming language such as Java, Smalltalk, VB.NET, Python, and Perl. Programmers also like object-oriented code because it is modular, reusable, and easy to maintain. Object-oriented terms and concepts would be unified modeling language. It's a method of visualizing and documenting an information system. Attributes is characteristics that describe the object. Methods, tasks or functions that objects perform. Message, a command to perform a method. Class, a group of similar objects. Instance, a specific member of a class. When we look at an object, it represented as a rectangle with the object name at the top, followed by the object attributes and the methods. So in the example shown on the right, you see that we have a driver object that is made up of the driver's license number, the age, etc. And we see that that object can send messages to the car object. Attributes are characteristics that describe the object. Characteristics can be in a student object. Things that describe a student would be the student number, the name, address, telephone, date of birth, fitness record, and status. Then they also list the methods that can be performed using the student object. Would be like add fitness class, drop a fitness class, change address, change telephone, change status, update fitness record. This is just an example of what an attribute would look like for a particular object. Then we have methods. Methods are specific tasks that an object can perform. For instance, if we had a method that was called more fries, then inside of that it will have all the steps that would be completed in order to complete that method. In the example shown, it would heat the oil, fill the fry pan with frozen potato strips, lower the basket into the hot oil, check for readiness. When ready, raise basket and let drain. Pour fries into a warming tray, add salt. So in this particular instance, this is an entire task that would have to be performed to complete the method more fries. Then you have messages. Messages is a command that tells an object to perform a certain method. The same method to two different objects can produce different results, called polymorphism. You can view an object as a black box. Message can trigger a change in the object without specifying how the changes must be carried out. An example would selecting gas at a gas cap. You don't know how it works. You just select it. Encapsulation, all data methods are self-contained. So you have, in this one, it shows you that an instructor would do a intergrade message to the student record. In a school information system, an instructor object sends an intergrade message to an instance of the student record class. In object modeling, we have unified modeling language. There's different diagrams that's used to show how an object-oriented system works. One is the use case diagram. It's a visual summary of several related use cases within a system or subsystem. The first step is to identify the system boundary, which is represented by a rectangle. System boundary shows what is included in the system and what is not included in the system. Here is an example of a use case diagram. We see that it shows all the interaction that a user would have with the system. In this particular, we have three different users. We have a customer, a mechanic, and a service writer. Let's just look at the customer. When we look at the customer, we'll see that the customer will request service. As a result of that service, it will perform an update, or it would create a work order, which is going to update the work schedule. And also, it's going to also create a prepare invoice. For the mechanic, once the request comes in, a work order is created, then the mechanic would be notified. Then the mechanic will perform the work, and that would be going to preparing the invoice. Now for the service writer, after the request comes in, he writes the work order, and then he also confirms that it has been done at the end. So this shows how work is performed within an auto service department. The next one we have here is one that creates a bus schedule. And here we have three users. We have a student, a dispatcher, and a driver. With the student, they will initiate a create requirements forecast, which is going to go to the dispatcher, who is going to determine what the route plan to do to prepare it. And they also develop the staffing plan. The driver then notifies of what the staffing plan is so that they might prepare their schedule. So this shows how three people are interacting all differently to a bus route system. With class diagram, it shows the object classes and the relationships involved in the use case. Each class appears as a rectangle with the class name at the top, followed by the class attributes and the methods. Lines show relationship between the classes and have labels identifying the actions that relates to the classes. The diagram also includes a concept called cardinality, which describes how instances of one class relate to instances of another class. Here it shows an example of a class diagram for a sales order use case, so that we see that we have a sales manager who is related to a sales rep, because each sales rep is managed by the sales manager. Also, we see that each sales manager can manage only one sales office. We also see that the sales rep also can only work out, one sales rep can work out a multiple sales office, and one sales rep can have multiple customers, and each customer can place multiple order that can be included in the invoice, the items ordered. With a sequence diagram, it's a dynamic model of a use case showing the interactions among classes during a specified time period. Graphically documents the use cases by showing the classes, the messages, and the timing of the messages. Include symbols that represent classes, lifelines, messages, and focuses. Here it shows you an example of a sequence diagram with two classes. Notice that the X that indicates the end of the class 2 lifeline. Also notice that each method is represented by a line with a label that describes the message, and each class has a focus that shows the period which messages are sent or received. This is another example of a sequence diagram for an add new student use case. The use case description for add new students is shown in figure 625 on page 240 of your text. The next diagram that we will look at is the state transition diagram. It shows how an object changes from one state to another depending on events that affect the object. All possible states must be documented in the state transition diagram. State appear as rounded rectangles with a state name inside. In this one, you'll see that there's 4 different states: new, active or existing, closed or former, and then frozen. This is an example of a state transaction diagram of a bank account. So it can either be when you open a new account, when you make first deposit, it becomes active and existing. When the bank closes the account or customer closes the account, it becomes closed or a former account. If something happened where for some reason that your account is frozen, then it would be frozen, and then it will go back to active when the assets are released. Then you have an activity diagram. It shows the actions and events as they occur. It shows the order in which the actions take place and identifies the outcome. In this diagram, it's an activity that shows the action and events involved in withdrawing cash from an ATM machine. We start by saying, okay, the customer needs cash. The customer inserts their ATM card into the machine. The card is accepted by the machine. The customer then enters their PIN number. The PIN is accepted. The customer requests cash. It then checks to see if sufficient funds are available. Then the ATM adjusts the balance, and then it provides the cash. If sufficient funds are not available, then it's going to go and it's going to notify the customer that the funds, or you have insufficient funds. So in that case, the customer would not actually be able to withdraw any funds at that time. When we look at business process modeling, it represents the people, events, and interaction in a system. Outside rectangle is called a pool and designates swim lanes, show specific actions and events. Swim lanes can interact when certain events occur. You have different modeling sites that can be used where there's free software that uses swimming pool and swim lanes to represent interactive business processes and events. You also have case tools that can be used, and this object modeling requires many types of diagrams to represent the proposed system. Creating the diagrams by hand is sometimes very time-consuming and tedious. Case tools speed up the process and provide an overall framework for documenting the system components. Case tools ensure consistency and provides common links so that once the objects are described and used in one part of the design, they can be reused multiple times without further effort.